Intelligent Transportation Systems Podcast. Welcome to the ITSPodcast. This is episode 27 for July 2015. I'm Javier Sanchez Medina from the Intelligent Transportation Systems Society. This is a special issue about the just wrapping up IEEE Intelligent Vehicles Symposium sponsored by the IEEE Intelligent Transportation Systems Society. We have prepared a selection of contents with some of the big names involved. As the main course, we have interviewed Professor Bart van Arem from Delft University of Technology, who was keynote at the conference. We talk about his lecture titled Automated Driving, the Futures Transport Starts Today. We also have some on-site comments from Professor Yi from Seoul National University, who acted as general co-chair, and Professor Chung from Hanyang University, who was program co-chair. Finally, we have our usual columns, the News Minisection by Dr. Maryam Kaveshgar, and the Transportation in History Minisection by Mehran Shirazi. So this is the plan. Let's start with the News Minisection. Please get comfortable and enjoy.
This is the News Minisection for episode 27, July 2015 by Maryam Kaveshgar. A few days ago, an autonomous car crash almost took place in the streets of California. Why autonomous? Because no human was involved, for the first time. The incident happened while two autonomous cars, a Google and a Delphi automotive, were driving through the Silicon Valley. Director of Delphi Silicon Valley Lab and Global Business Director for the company's automated driving program, John Absmeyer, was a passenger in Delphi's self-driving Audi Q5 when it was forced to take evasive action, avoiding a collision with a Lexus RX 400h autonomous vehicle operated by Google. The Audi Q5 was getting ready to change lanes when the Google self-driving car cut it off and forced the Audi to go back to its lane. Absmeyer told Reuters that the car took appropriate action. Google is quiet and has not commented on the incident. Google has been always very proud of its car's safety. A few weeks ago, Google announced that during the 6 years of its car operation, they had only 13 accidents. Google self-driving cars had covered more than 1 million miles. Interestingly, according to Google, all 13 accidents are the result of human error and not software malfunction. In the two recent ones, Google cars were rear-ended. Delphi is running two Audi prototypes in California, while Google has been testing more than 20 Lexus prototypes, and very recently it started testing its own prototype on the streets using the same softwares as in the Lexus. Like alleged Lexus, which was involved in the incident, they are also equipped with pedals and steering wheel and a driver for emergency. The new Google cars are like two-seaters Mini Coopers, which are limited to a speed of 25 miles per hour on the roads around the company's quarter in the Mountain View. Google has launched a website through which people can share their encounters with Google autonomous car. It is just a matter of time that any of these companies will release their driverless cars on public roads. Some people are eagerly waiting to hear the news that driverless cars are on the public roads, and some people are doubting the idea and find it terrifying. Let's see what the future holds.
Transportation in History by Mehran Shirazi, PhD candidate at Simon Fraser University, Canada. Animal-powered transportation. Apart from the horse family, donkeys, mules, and hinnies, there has been quite a lot of different species used to move people and goods all through the history. Camels, sled dogs, elephants, and reindeer are among the most well-known ones. But there are also other less common animals like water buffalo. In Thailand, the Chonburi Water Buffalo Racing Festival has been organized every year since more than 100 years ago. There are many other bovine, like oxen, used all over the world for pulling carts and wagons. In Himalayas, yaks are used for similar purposes, including racing in Tibet. Another rather unusual example is moose, whose domestication was investigated in the Soviet Union before World War II. To end with another not so common example, let's mention ostriches. Ostrich races are quite popular in some African countries, especially South Africa. But that's not just in Africa. In 1892, the ostrich farm opened in Florida, and there is the Ostrich Festival featuring ostrich races that has been celebrated all across the United States. Using animals for transportation is not limited to land animals. The United States Navy has used dolphins to detect and attach markers to sea mines. Do you know any other animals ever used in transportation? Let us know about it.
Okay, now it's the time for the on-site comments we managed to record to Professor Yi and Professor Chung. Very well, we are now at the Intelligent Vehicles Symposium here in Korea with Professor Yi, who is general co-chair of the event. Congratulations, Professor. How is it going? Are you satisfied with the resulting event?
Yeah, thank you. Yeah, so far we are very happy. This symposium seems to be going very well, and so far looks successful. Yeah. Mm-hmm. Also, it's my great pleasure to have this symposium in Seoul, Korea this year.
We are also with Professor Chung. Professor Chung is program chair. Professor, can you give us some statistics about, for example, how many papers, how many posters?
Yeah, we have 223 regular session, and 23 papers oral session, and 200 papers poster sessions. Uh-huh. And we have 6 workshops.
Fantastic.
On the Sunday.
Good. And I think that they're coming from everywhere.
Yes. So I haven't got the statistics yet, but
the paper is from 25 countries.
25 countries.
Yeah, 25 countries. 25. Yeah.
Fantastic. And how about the technical content? I think the quality is remarkable. Can you please tell us what are the main topics you are discussing here these days?
Actually, there's some more than 12 are the keywords for the intelligent vehicle. Mm-hmm. And so one was the ADAS system for the advanced driver system, mm-hmm. and vehicle environment perception, and vehicle control, and the image radar and LiDAR signal processing, and autonomous driving vehicles, and advanced driver system, another ADAS system, and autonomous internet of a vehicle system. So we have 6 regular sessions for selected 6 keywords. That is based on the number of submissions. Mm-hmm. So we consider the major submission area among keywords. Then we selected 6 oral sessions. Mm-hmm. And other many papers for different keywords was spread into 5. Mm-hmm. So we have 6 oral sessions and 5 poster sessions.
Excellent. Now, how about the industry participation? I mean, being here in Seoul, so crowded of high-tech industries, have they had their say in this event? Do you have? I know that you have a lot of supporters coming from the automotive industry. Have they add also technical content to the event?
Well, when I checked the paper submissions, also affiliations, I don't have a specific number yet, but because it's difficult for me to identify whether that is a industry or some government-sponsored institute or the academia. Mm-hmm. Roughly, and I think this symposium is more or less has a large number of industry participants than any other conference sponsored by IEEE. Mm-hmm. I attend many IEEE conference, but this is one of the symposium that has many participants from industry.
That's fantastic. Congratulations on that. And how about the students? With so many, technically based universities around, what do you think? Do you have a high presence of students here?
Oh yeah, many number of student registrations. About 30 to 40% is student registrations.
Wow.
Yeah.
Mm-hmm. That's good. Okay, that's it. Congratulations on this great success. Do you want to give any advice for future conferences of the ITS Society?
As the Professor Chung mentioned, so more close the collaboration between academia and the industry is very important in this automotive intelligent vehicle area. So for more participants from industries, some special programs, special workshop or special promoted programs. Mm-hmm. So some invitations without a special leave process would be very important for more industry participations.
Excellent. Thank you.
Okay. Thank you.
Professor.
Well, this morning I realized that there are many participants and the room is very crowded. So I can feel the heat from the participant because nowadays the autonomous driving intelligent vehicle is very popular.
I guess that's rewarding, right? Okay. Thank you. Very well. Let's jump now to the main content of this episode. Here we have Professor Van Arem's interview. If you like autonomous driving and you feel the excitement we are all feeling in the ITS community, you will like this one. Hello, we're today with Professor Van Arem. Bart Van Arem is full professor of transport modeling at Delft University of Technology. His research and teaching include impacts of intelligent vehicles and cooperative road vehicle systems and modeling of driver and travel behavior adaptation to ITS. He served as editor-in-chief of the IEEE Intelligent Transportation Systems Society newsletter and as general chair of both the 2008 IEEE Intelligent Vehicle Symposium and the 2013 IEEE ITSC conference. He currently works on control algorithms and behavioral adaptation of intelligent vehicles for the Dutch National Science Foundation, as well as several international public and private clients. In 2013, he founded the Dutch Automated Vehicle Initiative, or VAVI, resulting in a breakthrough in the Netherlands' automated driving interests. Hello, Professor Van Arem. Thank you very much for joining us today. Can you please introduce yourself and tell us about the center you run?
Yes, and hello, Javier, and thanks for inviting me for this ITS podcast. I think that's a great initiative, and I'm delighted to speak there. So I have a background in mathematics. I always liked applied modeling in mathematics, and I knew quite from the start that I wanted to apply this to traffic flows. And as my experience grew, I discovered intelligent vehicles, and the interaction of intelligent vehicles with traffic flow is a subject that I really like to model. And I've been working in this field since the early 90s, studying with the impacts of adaptive cruise control on traffic, see how it changes, and nowadays I more or less do the same, but in much more detail. We have different types of automation. We have different types of behavioral adaptation that we consider, and at the moment leading a research group, a research center at Delft University of Technology. I work at the Faculty of Civil Engineering and Geosciences in the Department of Transport and Planning. And the Department of Transport and Planning, we have about 60 to 70 people working there. 20 of them are permanent staff members, and the other ones are PhDs and postdocs. And we work on the planning and design of transport systems and the operations and management of transport systems. And one of the focus points of our research nowadays is traffic management. And traffic management now is also changing because of intelligent vehicles. We have very different traffic flows that are merging at the moment. In addition, I'm also leading an initiative called the Dutch Automated Vehicle Initiative, which is a multidisciplinary research program in which also mechanical engineering is involved, information sciences is involved, as well as civil engineering. And we have a number of test vehicles on automated driving.
Good. Professor Van Arem has just made a keynote speech at the Intelligent Vehicles Symposium in Seoul, Korea. And the title of his talk was Automated Driving, the Future of Transport Starts Today. So that seems like a very challenging title for a talk. Please tell us, what was it all about?
Well, I chose this title because actually the work that we are doing in the intelligent vehicle field has been exploding during the last years, and the expectations are really high. So there are a lot of expectations on how intelligent vehicles improve traffic safety, how they could reduce congestion, and how they could even completely lead to a revolution in transport. Some of those thoughts might be wishful thinking, but what you also see is that we're taking very serious steps at the moment in solving real problems with intelligent vehicles. And it's an amazing field, and a lot is happening. We will have a lot of changes by intelligent vehicles, and actually the work we're doing today will be the basis of that work.
Professor, there are quite a few of automated transportation means we are already using, right? Maybe more than what we are aware of. So can you give us some examples?
Yes, we're actually the introduction of automated vehicle systems and intelligent vehicles. It has been going on for several years already, and systems like adaptive cruise control, lane departure warning, lane keeping, they have not been known very widely in the past, but today they're becoming quite common. And in luxury cars, you see it as a regular option that is taken. Sometimes it may be even standard. So a lot of people know about these systems and appreciate how they're going to use it. What we also see is that there are some other applications of automated vehicles, such as automated shuttles. In the Netherlands, close to Rotterdam, we have been having a service of an automated shuttle at Rivium. So it connects a metro station to a business park. And this has been in operation for about 15 years already. So it's on a very protected track. So there are fences along the track. Nothing can happen on the track. And this vehicle has been driving automatically since many years already. And at the moment, we are considering new applications that are more out in the open traffic. So we're trying to expand our experience in that direction. Mm-hmm. At the same time, what we see in the port of Rotterdam is that containers are transported fully automatically. So also there, it's a protected environment which is known and in which the vehicles are capable to navigate. But you see also new applications coming up in research, such as truck platooning. Truck platooning is not on the market yet. It's not available yet, but I expect this is one of the applications that is going to come soon.
Mm-hmm. That's interesting. You also talk about the influence on traffic behavior that automatic vehicles may pose. Can you tell us what can happen? For example, will we use our roads more efficiently, or will the careful computers provoke a rise in traffic demand? I mean, we have unsafe human drivers, but we also have skilled human drivers. So will we automated or mixed automated and manual traffic behave more efficiently than our traditional manual traffic?
Well, it sounds so easy that if we replace human drivers by intelligent vehicles, then things would be much safer and much more efficient. But actually, there are a number of things that human drivers are pretty skilled in, and which pose considerable challenges to intelligent vehicles. So what we see that on a straight long road, you could have intelligent vehicles reach capacity of a lane up to about 7,000 or 8,000 vehicles an hour. This is huge, but the problems, the traffic efficiency problems, are not in straight lanes. These problems are at discontinuities. So, for instance, at discontinuity, if you have a area where the traffic merges from a 4-lane motorway to a 3-lane motorway, that is a challenge for regular drivers, but it's also a challenge for intelligent vehicles. So imagine an intelligent vehicle operating there more efficiently than a human driver. That is a serious design and engineering problem that we need to tackle. Also on the secondary roads, the urban roads, these are very crowded roads, and this is also a challenge for intelligent vehicles to drive safely. Safely is the first challenge, but have it efficiently and more efficient than human drivers, that's a next and pretty serious challenge. Another challenge that we have there is when we have different levels of automation on our road networks, then we have the need of different transitions between those different levels. So these are authority transitions. So what happens if a driver transfers control to the vehicle? That may be a problem that's maybe easy to solve, but it becomes more complicated when the control of the vehicle needs to be transferred back to the driver again. For instance, if the vehicle is approaching a road where a lower level of automation is applicable. So the vehicle then asks the driver to take over, but what happens if the driver does not take over, and in which conditions can this happen? And this actually may lead to complete new moving bottlenecks in our road network that would deserve our attention. Another discontinuity that we could address is platooning. So if we have a very efficient platoon that reaches very high capacities, the challenge is, how do you form a platoon? So how does the process of vehicles taking their positions and after that reducing the distances between the vehicles, how does it take place and how much space do you need for that? And the same holds when a platoon needs to be dissolved. So those are some of the questions that we need to address in automated vehicles and traffic efficiency. There are some positive signs already. So, for instance, if we do have congestion driving and traffic jam assist, this is a very positive development already, because a traffic jam assist system drives in a more regular way in congestion than a normal driver would do. And also, when congestion is over, an automatic system will resume normal control automatically and instantaneously, whereas normal drivers sometimes tend to hesitate, and it takes a while before they resume their normal driving behavior again. This is also a cause of congestion that is on the road too long. So this is a way that intelligent vehicles could help solve congestion much more quickly once it has occurred. You're also referring to some of the impacts that if our roads are used more efficiently, will that lead to additional demand? And the answer probably is yes. If the roads have a higher capacity and there is less congestion, then the quality of the trip improves, and this will attract new travelers in the same way that if you build an additional lane at the motorway, this also attracts more demand. So this is a known fact from transport systems. An additional driver in this field is also that driving becomes more attractive. So people will not mind so much being in a car because they can spend their time differently compared to manual driving. So if you have the higher levels of automation, people can do other things like reading their email, reading a book, or doing what they would like. And what I also expect that even at the lower level of automation, where the driver is still involved, this also leads to additional comfort and additional attractivity of the car.
Mm-hmm. Professor, do you think that we will eventually eliminate manual driving? Do you think our society will accept that? Or how about lawmakers and insurance companies?
Well, the answer to that would be yes and maybe. The yes part is that it's already there. We do have systems without a driver. So I mentioned the public transport system that is completely without a driver. And this is allowed on special tracks that we have. And we are experimenting in expanding geographical scope of this. And for instance, in the Netherlands, our vehicle type approval authority is very close involved in this development. So in that case, it's a yes, but it has very specific regulations and laws under which this is permitted. Mm-hmm. The maybe part is referring to fully hands-off, feet-off, brain-off driving from door to door. That's level 5 of the SAE definition. That's difficult to tell, and I've seen several studies that have been devoted to the future development of automated driving, and these studies, they started actually in the 50s of the last century, and they have been done in the 60s and 70s and 90s. And there's one thing that is very consistent amongst these studies, that this level of automation is predicted in a time horizon of about 20 years. So if you ask experts today, they would probably say that it's 2015 now, so it would be beyond 2035. So we'll probably have 2035 with full automation. When I look back at the previous studies that were done, maybe that's a way of saying, okay, we're quite certain of the first 10, 15 years, but what comes after that is still unclear. And there's, of course, a lot of societal challenges that needs to be addressed there in terms of acceptance of the systems. What I see is that the acceptance is developing in a positive way, because typically acceptance of automated driving is low when people have not experienced automated driving. But nowadays you see that if we have systems like traffic jam assist, we have systems like automated parking, people really appreciate those systems, and it has a very positive image to people. So the acceptance is increasing, the costs are decreasing. Yes, we'll have legal problems to solve, but for the legal problems, I could refer to the fact that adaptive cruise control was put on the market in 96, 97, 98, and in the Geneva Convention, it's being made possible only this year. So in that fact, regulations has been laid for more than 15 years. So I don't think that we should let ourselves be restricted to regulations too much. I think the success of the introduction of adaptive cruise control was because the industry was able to show that it's a safe system, the system is operational, and system is also well appreciated by the users. And I think that also for the higher levels of automation, this would be the way to go. So we need to show that it's safe under all conditions, and there will be no concessions in this area. And in addition, those systems that really provide value to the customers, those will be the systems that take off in the market first. There's also a potential that vehicle automation is being combined with vehicle sharing. So there is a tendency that people appreciate the use of a car over the possession of a car. And that means that vehicle sharing is becoming more popular. Then the vehicle is being used more. There's a larger turnover of vehicles. You can have quicker technological development. Also, the price per kilometer is lower. And if you have a vehicle sharing system in which vehicles can be relocated to the persons that are demanding a vehicle at a certain location, you could do that automatically. So this gives also additional possibilities there. So the maybe part, yes, we're certainly progressing, and I would expect in a good tradition with the previous colleague making these predictions, that level 5 would be somewhere beyond 20 years.
Thank you, Professor. Well, we now need to make a very short break. We'll be back in a few seconds, so please stay tuned. Hello again. Do you want to get a warning to your email with every new podcast? It's easy. Visit ITSP.cicei.com. There you can subscribe by entering your email address both at the right side widget or the bottom right follow tag. Once introduced to your email, you will get a confirmation message where you should click in the activation link it contains. Do you know that the IEEE Intelligent Transportation System Society has a Twitter account where you can follow all about the ITS podcast and a lot more? Search for ITSSIEEE. We also have a Facebook page. Same instructions, search for ITSSIEEE. Please join us. And here's one final piece of information. If you are an IEEE Intelligent Transportation System Society member, we are collecting nominations for its Board of Governors election that will happen next fall. So, if you have someone in mind, or if you want to self-nominate, please visit this episode's post at ITSP.cicei.com and you'll get more information. ITSP.cicei.com. Thanks for listening to the ITS podcast. Let's get back to our today's interview. Hi, we're back with Professor Van Arem. Professor, how about sustainability? I recently heard from a colleague that automated transmission vehicles do have a higher carbon footprint than our European manual transmission cars. So, can autonomous or automated driving bring us more sustainable mobility now that it seems that we urgently need it? What do you think?
That's really an interesting question. And of course, if automated vehicles can also contribute to better sustainability, the business case is even better. And I think there are some good reasons for thinking that it is indeed the case. So when we look at the possibilities of automated driving to solve congestion, this is one of the primary ways in which you can improve sustainability, because emissions and more general the use of energy is much higher when vehicles are in congestion. So in that case, if you solve congestion, you solve some of the sustainability problems. In addition, when you compare automated driving with manual driving, automated driving is much more smooth. And manual drivers are, of course, in general good drivers, but as a controller, they're not very stable. So in this case, also having a more precise and smooth control by automated vehicles can reduce fuel consumption.
Good.
And the third option is already has been mentioned, that is associated with platooning. In platooning, what you can do is you can reduce the aerodynamic drag of the vehicles that are in a platoon, and so both the vehicles that are following, they save fuel, but also the first vehicle, it also saves fuel because there is no turbulence behind the vehicle anymore.
Very interesting. And here's another one. Professor, how about equity? Do you foresee a positive impact of autonomous or automated mobility in, for example, impaired or elder users?
In terms of equity, there are different angles. When we look at the impaired people or disabled people, yes, automated vehicles can help them in controlling the cars. Some driving aids are already available, but I would say here that there's always, as long as you have transitions between different levels of driving, the driver still needs to be capable of driving on normal roads. So if you go as far as people with visual disability being able to drive because the vehicle is doing the driving, then there is still the challenge on the non-automated roads that they are not able to drive. But for instance, systems like parking, automated parking, this is a complicated maneuver for a lot of people, and automated driving can help there for sure. So, and for instance, people afraid of driving in a parking garage, automated driving can help there as well. Another dimension of equity is, of course, also the fact that automated driving could be introduced first on the very expensive cars, and therefore the rich people in society, they get a benefit before the other parts of the populations get the benefit. This is also a political problem, an equity problem, and for instance, one of the reasons why in the Netherlands a subsidy for vehicles with ACC has been a difficult subject for politicians, because if you would subsidize adaptive cruise control, you would be subsidizing expensive vehicles that are bought by the rich people and not by the common people. So there's an equity problem there, and what we see is that, and I'm happy to see that also at smaller cars, we do see some driver assist systems that are appearing there, such as blind spot monitoring on very small cars, and also medium-sized cars you have adaptive cruise control. So it's progressing there, but it has been progressing low because of this equity problem, which prevented authorities on providing subsidies.
That's interesting. And I think we're not talking enough about it yet. Professor, you know that in our field, we have a huge movement now on transportation electrification. So from your perspective, how does it play together, autonomous driving and transportation electrification?
I've been noticing the same, and what you see in a lot of pilots, especially in automated public transport, the combination with electric vehicles is made a lot. And from a technical point of view, there are some advantages in taking over the control of an electric vehicle, and at the same time, it's a combination of a sustainable and a smart and comfortable technology that's very logical to combine. I've seen research on what I would consider a kind of the ultimate symbiosis of electrification and automation, is where the energy, the electricity is transferred inductive via induction from the road. So you have cables or induction in the road, and the vehicle picks up the energy. So just like a tram or a train, but then from the ground. And by doing that, you can also save batteries in the vehicles, because you only need a battery to drive to the road, and then the road will provide you with the energy. The combination with automation is interesting in that part, because the automation will allow you not only to drive efficiently, but also to optimize the energy transfer and the percentage of energy that's really put to a good use. And the automation can help position the vehicle in the right way to do that.
Mm-hmm. Well, it's a pity, but we are reaching the end of this interview. I'm liking it so much. So here's one final question. From all the challenges you mentioned, what do you think is the most important one? What's the big challenge now ahead regarding automated driving?
Regarding automated driving, I think the main challenge that we are facing today is to get vehicles on the road and to get experience and to share the experience. So a lot of pilots are being done, but I see too little results of the experience from the pilots. How do users appreciate the different types of systems? In which conditions did that take place? And I think we could accelerate our research if we would share this data amongst the different research groups at universities and industries around the world. I think these results are still kept too much inside the different institutions, and sharing that, again, I repeat, it would accelerate our research, and I think everybody's research.
Okay, Professor, thank you very much for this very interesting interview. I think our followers will be delighted with it. Goodbye.
Goodbye, my pleasure.
Well, this episode is over. We hope you liked it. Please help us disseminating this publication among your colleagues and sending your feedback through any of our social media accounts. We are already preparing our next episode. Don't miss it. This podcast is sponsored by the IEEE Intelligent Transportation System Society, website designed and managed by the Innovation Center for the Information Society at the University of Las Palmas de Gran Canaria in Spain. Soundtrack developed by Rubicon, language advisory by Manuel Arbelo and Professor Song Williams from Kyongsu University in South Carolina. We'll be back soon bringing you again the cutting edge of science at the Intelligent Transportation Systems podcast. Thanks for listening and drive safe.